Okay, let's finish up on radiocarbon dating. So many people who have listened to evolutionists and preachers from the pulpit, scientists everywhere, who uphold the wonders of radiocarbon dating, can detect when the dinosaurs left 65 million years ago and so on and so forth. It's just untrue, and the method is unreliable. We get to BibleStudyManuals.net, K55.htm. Down here, a statement in science. Remember, I'm not a scientist. I'm just reporting what scientists are saying on both sides. Yes, I see that scientists, when they go into depth on the reliability of a method like radiocarbon dating, even they get to be a little bit more honest on the evolutionary side. We notice a statement reported in Science on an international conference of 145 experts in this field. And they say throughout the conference, emphasis was placed on the fact that laboratories do not measure ages. They measure sample activities. Is that called backpedaling? The connection between activity and age is made through a set of assumptions. One of the main assumptions of carbon-14 dating is that the atmospheric radiocarbon level has held steady over the age range to which the method applies, which is so far still not true because we haven't reached equilibrium between what goes in and what comes out of carbon-14 in the atmosphere. In other words, the conclusion is that we got the same amount of carbon-14 now than we had when this critter died that we're trying to date. However, we have seen clear indications that that is not a valid assumption, as we see the ages varying drastically. We know that this is not the case because the level of carbon-14 has been measured to be increasing still, right now in this day and age. It was thought to be at equilibrium. If we use the analogy of the faucet pouring water into a tube, then for the sake of the illustration, we'll assume that it's infinitely high. As this column of water increases in the tube, then the weight of water would increase and would force the water out faster at the bottom. Now, when the rate of flow at the bottom increases to the point where it equals the rate of formation at the entrance at the top, okay, now we have the level of remaining constant. Now we can measure by that. It would stay the same. If you have as much flowing water into a laboratory as flowing out of the level, is going to stay the same. We have measured and found that the carbon-14 in the atmosphere is 30% short of equilibrium. So it's not staying the same. Now this has been done at UCLA and a number of other places and by author Lubenow himself. Lubenow's original work, for which he won the Nobel Prize, scientists determined that it would take less than 30,000 years to reach a state of equilibrium. However, it's still 30% short. Now, this is not a linear process. It's an exponential process. It slows down as it approaches equilibrium. And you can calculate how long it would take to reach the present level. And it comes out to be something less than 8,000 years. Not 880, not 800,000, not 8 million, 8,000 years, equilibrium. That certainly fits the picture of the creationist and the young age of the earth much better than the evolutionist. If it only takes 30,000 years to get to equilibrium and it's not there, I think we can see very clearly what the straightforward facts indicate. And when you calculate how long it would take to get to where we are today, and we see a few thousand years more, then obviously there's a good reason for radiocarbon to say that the Earth is only a few thousand years old. You must make a number of assumptions contrary to what we observe in order to get it to come out older. Now we can make assumptions that rates remain constant and that the observations we make hold true over a few thousand years. And that process is really scientifically more valid than if these rates were to be assumed as remaining constant over billions of years. For example, you have a 1% error over 8,000 years, you're not going too far afield. Over billions of years, yeah. And when we do assume a constant rate over a short period of time with a number of indicators, we see a very clear indication of a young age for the Earth. carbon dating supports a young Earth. Dr. Patton says H.E. Seuss of UCLA presented the latest determinations as deduced from the current activity of chronologically dated growth rings of the Californian bristle cone pine. They got big words there. The carbon-14 concentration indicated that the concentration increases. So we're still not reached equilibrium. Therefore, Seuss says, the content of carbon-14 in organic matter is still on the increase, not having reached equilibrium yet, which takes an estimated 30,000 years. That testifies to a young Earth. Don't forget, 30,000 years, but it started off going much faster, slows down as it reaches equilibrium. Pre-flood period carbon-14 proportions are not factored in. Suppose there was a worldwide flood. Suppose, since the water would be presumed in part or wholly to come from above. Okay? So that might reduce the cosmic radiation. And carbon-14 rate of deterioration and or increase would be highly affected. So anyway, it says prior to the flood, it is highly probable that the ratio of ordinary carbon to radiocarbon in the atmosphere was much higher than at present, mainly because of the global semi-tropical climate and the vast amounts of plant life found around the world. You know, you can see that in the fossil record, all the plant life. This effect would have been augmented by the smaller amount of carbon sustained in the ocean then than now, since the oceans were smaller and the land areas larger before the flood. And it is possible that it would be still further augmented by the shielding effect of the thermal canopy, which would have inhibited the formation of radiocarbon in the high atmosphere. All of these factors would have reduced the ratio of radiocarbon to ordinary carbon to a much smaller fraction than now obtains. You have to factor that in. Another possible effect of the canopy is very interesting. In addition to the formation of carbon-14 from nitrogen in the atmosphere by cosmic ray neutrons, these neutrons also react with deuterium, which is heavy hydrogen, the hydrogen isotope in heavy water, which would undoubtedly have been present in substantial amounts in such a canopy to form tritium, a still heavier isotope of hydrogen. Tritium is unstable and decays rapidly by beta decay to an isotope of helium, helium-3. But it turns out that there is too much helium-3 in the atmosphere to be accounted for by this process operating at present rates during geologic time. So the Cosmic Ray Authority, CORF, he's a scientist, suggests the following solution to the problem. There are two factors which tend to increase the amount of tritium. One of these is that the intensity of cosmic radiation, and hence the rate of production of neutrons, might have been higher at some time in the geologic past. I don't know if he's understanding, he's agreeing with creationists. The second possibility invoking action in the past assumes that at a time when the Earth was warmer, the atmosphere contained much more water vapor. Hello? And the process of generating tritium from deuterium might have been operating at a much higher rate than at present. Different rates. You can't assume things are the same as we see them today. So Korf goes on, the canopy thus not only provides an explanation for the present excess of atmospheric helium-3, but also implies that the proportion of cosmic ray neutrons reacting with nitrogen to form radiocarbon would be smaller by the amount reacting thus with the hydrogen. This factor combines with others mentioned to assure that the percent of radiocarbon in the carbon dioxide of the antediluvian atmosphere must have been much smaller than at present. Therefore, the radioactivity of living organisms ingesting the carbon dioxide would have been much smaller as well than that of organisms living at present. Thus, antediluvian organic matter probably would now have little or no radioactivity if preserved as fossils, even though they may actually have been buried by the flood only a few thousand years ago. Although present radiocarbon activity seems to indicate measurements which detect radioactivities from matter perhaps as much as 70,000 years old, such indications are based upon the assumption of uniformity. This stricture is considered quite serious by Dr. Plas, another scientist who is a specialist in investigations dealing with atmospheric carbon dioxide. As a scientist, all calculations of radiocarbon dates have been made on the assumption that the amount of atmospheric carbon dioxide has remained constant. If the theory presented here of carbon dioxide variations in the atmosphere is correct, then the reduced carbon dioxide amount at the time of the last glaciation means that all radiocarbon dates for events before the recession of the glaciers are in question. That's Gilbert Plas, Carbon Dioxide and the Climate, American scientist. He's a scientist. I'm not. Go by his words. Don't criticize me for what he wrote. Post-flood period carbon-14 proportions dramatically higher. With respect to plants and animals living after the flood, the loss of Earth's canopy would tend to increase the percent concentration of carbon-14 in the carbon dioxide of the atmosphere, since the rates of formation of carbon-14 atoms would be accelerated by the loss of the canopy. Lots more radiation in the atmosphere now go directly from the space outside the sun. On the other hand, the influx of carbon into the atmosphere from the intense volcanism during and after the deluge period must have greatly augmented the carbon dioxide as well, the content of the atmosphere and oceans as well, probably more than offsetting the increase in carbon-14 at least for some time. Furthermore, the equilibrium condition between generation and decay of radiocarbon, which has to be assumed in making any age calculations by this method, would obviously not be applicable for quite a long time after the deluge, although there quite probably was a marked increase in rate of formation of carbon-14 atoms at the time of the deluge due to the greater effectiveness of the cosmic radiation in this process after the precipitation of the canopy. It would necessarily have taken many years for the total amount of radiocarbon to have built up a reservoir of such size that the number of atoms being created and dissipated were equal. So far, we still haven't reached that equilibrium. And this would mean that organisms living in these early years and centuries after the flood would have received a proportionately smaller amount of radiocarbon into their system than those living in later times, especially in the few hundred years immediately after the flood, during the time when mixing of the atmospheric, oceanic, and biologic carbon was first being accomplished. Would this be true? In his definitive book on the subject, Libby says, he's a scientist, if one were to imagine that the cosmic radiation had been turned off until a short while ago, the enormous amount of radiocarbon necessary to the equilibrium state would not have been manufactured, and the specific radioactivity of living matter would be much less than the rate of production calculated from neutron intensity. Radiocarbon dating by Libby. The obvious conclusion is that plants and animals living in the early centuries after the flood would have much less radioactivity than would be assumed on the basis of present rates, and would therefore appear to be older than they are. See? Old age, because you're not assuming the reality of the differences in the rates before and after the flood, or that everything you see today, the uniformitarian rates, are the same. No, it's not. We have evidence of catastrophism throughout the world. The specific radioactivity increased as time went on, would approaching the present equilibrium rates. That is why radiocarbon dates for the last 4,000 years seem to show a generally good correlation with historically verified chronology, although there are many discrepancies and a large margin of error the further back in time comparisons are made. But for earlier dates, the specific radioactivity in the terrestrial environment becomes progressively smaller as one goes back in time. Therefore, when material older than, say, about 4,000 years is analyzed now for radiocarbon, it would certainly be found that the activity was low. And if the age were